Alright, so another beautiful day in CCNA3, Chapter 3. Woo, the double threes. So, it's actually a fairly short chapter because we've already talked about it mostly. So, it is link aggregation, also known as port channels, also known as ether channels, also known as how many words can we say that mean almost the exact same thing. So, upon completion of this chapter, you will be able to describe link aggregation, describe ether channel technology, configure link aggregation with ether channel, troubleshoot link aggregation with ether channel. Alright, so what do we have? Imagine this. Nah, we're not going to imagine that. Introduction to link aggregation. So as we know from our last chapter, if we're just running spanning tree, this is going to get blocked. Why? Because it's a redundant path, right? It's blocking it so we don't have a layer 2 loop, which is what spanning tree is doing. Alright? So what are we doing? We're just wasting this link. We're just wasting these links. They're not traveling on both, right? And so that's why we do link aggregation. Right? Because what link aggregation is going to do is, one, it's represented by the circle, right, or ether channel. And so now what it's going to do is this is all going to be calculated as one spanning tree algorithm, like as one port. And we can do up to 8 ports on this, right? And we can increase speed, and it's probably one of the best things ever, right? So let's see. Most configuration tasks can be done on an ether channel interface instead of an individual port, which we kind of build like we have the SVI, you know, interface VLAN 1, interface VLAN 2, whatever it is. We build a similar thing when we're doing ether channel, right? And so then we do all the configuration through it, or most of the configuration through it. Ether channel relies on existing switch ports. There is no need to upgrade the link to a faster and more expensive connection to have more bandwidth, right? We don't need these to be 10 gig. If we don't really need 10 gig, we can feed 8 gig with 8 different ports, which we probably wouldn't. Or we could have 2 10 gig ports and, you know, get 20 gig. We could go to 40 gig. Anyways, it saves money, increases speed, because we're just using the same thing. Load balancing takes place between links that are part of the same ether channel depending on the hardware platform. One or more load balancing methods can be implemented. These methods include source MAC to destination MAC load balancing, or source IP to destination IP load balancing across the physical links. Ether channel creates an aggregation that is seen as one logical link. When several ether channel bundles exist between 2 switches, STP may block one of the bundles to prevent switching loops. When STP blocks one of the redundant links, it blocks the entire ether channel. This blocks all ports belonging to that ether channel link. Okay, so that's what I was saying, is it calculates these bundles as one spanning tree calculation. Alright, it's one cable basically. Ether channel provides redundancy because the overall link is seen as one logical connection. Additionally, the loss of one physical link within the channel does not create change in the topology. Therefore, a spanning tree recalculation is not required, assuming at least one physical link is present. The ether channel remains functional even if its overall throughput decreases because of a loss link within the ether channel. Yeah, so ether channel is going to help us get that 99.9999, that's 4 nines after the 99, uptime. It's great. So implementation restrictions. We can only use 8 ports. What else? I don't know. Let's see. The Ethernet provides full duplex with up to 800 meg or 8 gig, depending if they're 100 meg or gig. Oh, they have to all be. We can't put like some of them here and some of them here. They have to be in a row. That's about it. Wait. The Cisco IOS can currently support 6 ether channels, so that's actually 6 logical interfaces. Yeah, so you can have 6 Ethernet bundles on a single switch. I can't think of anything else that's important. Okay. So, we just go back. Alright, I apologize for that. So we have different types, as we do with everything, trunking and everything else. We have different types of ether channels. So one of them is PAGP, or Port Aggregation Protocol. Okay, we know it's Cisco because just like DTP, remember that dynamic trunking protocol where it's dynamic desirable, it has desirable and auto. Alright, so that's how you can tell that it's a Cisco. It also has on, but you can use on, I think, in either mode. So PAGP is Cisco proprietary and aids in the automatic creation of ether channel links and so on. So how does it form? If we put both sides to on, it forms. If one side's on auto or desirable, the other side's on desirable, it forms. If one side's on and desirable, it doesn't. If it's on anything besides desirable, or desirable and auto, it doesn't, or it has to be on and on to form. Okay, so that's PAGP, Cisco proprietary, which means it only is supported with Cisco switches. Then we use LACP, and so LACP is not only used, it's an open standard IEEE. It's not only used between switches, but this is what you're going to do in virtualization when you're going to bundle some server ports into an ether channel for redundancy or higher throughput. And so once again, it has its on mode because it's not using any protocol. Otherwise, it's active and passive. So basically, one side has to be active, the other side has to be active, or the other side has to be passive, and one side has to be active. If they're both passive, it doesn't work. If one side's on, one side's active, it doesn't work. Yeah. If one side's not configured, it doesn't work. Okay. So, what does this actually mean? How to configure it? Well, they have to be... Why isn't this one formed? What are we doing here? Okay, so one side is full duplex, one side's half duplex, so it's not going to form. This side will form because they're both on full duplex. So basically all your port configurations have to be the same. You can't form a gig link with a 100 meg link. They all have to be the same. They have to be in the same Ethernet channel protocol. They have to be the same speed and duplex. They have to have a VLAN match. They can't be in different VLANs. What's this range of VLANs? An Ethernet channel supports the same allowed range. Oh, so this is just, if you're doing trunking and doing allowed range in your trunk, they both have to allow the same or traffic's not going to flow, just like if it was a normal link. Okay. We go on. How do we configure them? So first, we decide what ports we want in there. And so we do an interface range command, right? So interface range F01-2, and then we say channel dash group 1, or whatever number you want to use, mode active. And so that's saying that we're going to do LACP, right? Because we said mode active. This is where you say mode active, mode on, mode passive, mode dynamic, mode desirable, or mode passive. I think that's right. No, active, passive, desirable, and auto. Yeah, it's dynamic, desirable, or dynamic auto. But we're doing LACP, so this is going to be mode active, right? Okay, so now we put those in there, so then we exit out of there and we say interface port channel 1. Alright, so that brings us into this channel group 1. And so this is like the SVI. We can do our programming there, and it's going to affect the ports in port channel 1. So we can say switch port mode trunk, switch port trunk allowed VLANs, and we can do all of our configuration from this virtual port channel, and I believe if you wanted to shorthand it, it's PO1. You could do PO space 1 and it's going to work. Anyhow, so that's LACP. If we're going to do dynamic, we go back over here. Did I skip? Must skip PAGP. Anyways, so if we want to do PAGP, oh, here it is too. Nope. That's you configuring. So if you want to do PAGP, I'll just do it over here. Just a second. We'll bring a packet tracer in. F03. Oh no, they have to be consecutive. Oh no! So I bring these guys over here, and I say enable. And what I have right now is if we did a show CDP neighbors, it shows me that I'm connected to, well, I don't have the switch's name, so it's kind of confusing, but 1 and 2 go to that switch over there, and that's it. Alright, so I say configure terminal, and I say interface range F01-2. That puts me in there, and I say channel. Got to type this out because it could be channel group or channel protocol. So I say channel group 1. Oops, didn't finish it. Channel group 1. What? Got to pick if I am LACP or PGAGP or no protocol at all. So I say channel group 1 mode. What are my modes? I guess it's not dynamic, it's just desirable. So I say channel group 1 mode desirable, right? Because I'm setting up PAGP. Alright. So bam, set up that side. So I set that side up for desirable. I'm going to go over here with the same configuration. I say config terminal. No, I say enable first. Enable, config terminal, interface range, it's the same, F01-2, channel group 1 mode, and this time I'm going to go auto to form the other side. So I say auto, and then I say interface PO1 to go into port channel 1, and at this point I really don't have to do anything because they're in the same VLAN. So that's it, but I could put trunking on if I wanted to, or just keep that in a VLAN, do whatever I wanted to, but that's establishing PDAGP, since I don't see where it's showing us that. Anyhow, we'll move on. So troubleshooting ether channel. Usually it's a trunking issue, or you did put your active side on. Also, a good choice is to shut down these ports that are in that before they form, because if one comes up before the other, it won't form that port channel well. But so our show command is show Ethernet channel summary. What else we have? Show run. And that's all I see there. So check those out. Form your own. Build both an LACP ether channel and packet tracer and a PAGP, and form a trunk across them and do those show commands, because I think there's more on those show commands. Your test has a lot of show commands on them, so make sure you look at all of your, here we go, show Ethernet channel summary, show Ethernet channel port channel, show interfaces ether channel. Alright, so show interface port channel, what's it going to do? Displays the general status of the port channel. That's figure 1. So it doesn't show us a whole lot. Then show ether channel summary. Actually says, we're in PO1, it's using LACP, and it's with F01 and F02, and this P means passive. Then we go to 3, show ether channel port channel. So it says, hey, once again, we're in PO1. It's the primary aggregator. All this jazz. I don't know what the logical slot, what it's trying to say. Protocol is LACP. Port security is disabled, so we don't have max security on there. Then it goes, this is our index for our ports. And this is the load balancing, or what's actually the traffic going across. Status active. I'm not sure what the number of bits means, but anyways. So then we go to show interfaces F01 ether channel. So this is the actual port. So if we want to see what the port's doing, it shows us what it's in. This is our spanning tree priority, which is 32768, which I'm sure you guys remember from last chapter, is the default. Yeah. What's our fifth one? Oh, you can try those commands. That's probably a good idea, because I'm telling you, this test is heavy on LACP. So that was that chapter. Wow, only 15 minutes. What a good day that is. You guys enjoy.